Welcome to Network Analysis. Here in this module 1, we have studied practical sources, source transformation. Practical sources means here voltage source and current source. And we have solved some problem on V to I transform and I to V transform. Also, network reduction using star delta transformation. That means star to delta and delta to star. We have solved some problems on this. So in this session, we work out some problems on loop and node analysis with independent and dependent sources with AC and DC networks. Please refer the notes that is shared in SPIT department blog. All the problems are explained from the notes that is displayed from the blog only. So here is one problem. Here is the problem which we'll work on. Loop analysis. So this is the statement of the problem. Find the current through 30 ohm resistor in the network shown using loop analysis. So here we are using Kirchhoff voltage law in order to write the equation for that is loop 1. So this is loop 1 and this is loop 2 and this is loop 3. So let us consider the current I1, I2 and I3 that is flowing in the clockwise direction. So with respect to the loop 1, we can write the following equation. So we have to consider the sign convention. If we are moving from negative to positive, we are going to consider that voltage as positive. If we are moving from positive to negative here, while writing KVL, we are going to consider that voltage as negative. If the direction of assumed current is clockwise, if we are moving in direction of the assumed current, we are going to consider negative voltage drop. If we are in the opposite direction of the flow of assumed current, then that will be positive voltage drop. So with this, we are going to write the sign convention equations. So the first equation will be 100 minus, that is this one. Here you can check the equation that is written there. So 100 minus 15I1, I am moving in the direction, minus here 20, I am moving in the direction, minus 20 I1 and I2 is in opposite direction. Therefore, minus 20 I1 minus I2. So on simplifying this equation, I am going to get minus 35 I1 plus 20 I2 is equal to minus 100. Similarly, let us write the loop equation for second mesh that is shown. So there are three resistance present here, no voltage source. Therefore, minus 5I2. Here 30 resistance. I am in the direction of assumed current. Therefore, minus 30, that is I2, and I3 is in opposite direction. Therefore, I2 minus I3. Again here, minus 20 I2 minus I1. Here I1 is positive and I3 is positive here. So So on simplifying this equation, we are going to get 20I1 minus 55I2 is equal to 0. Now writing the loop equation for third mesh as shown here with voltage source. So let us consider this. So I am now moving in the direction of current assumed, therefore minus 5I3. I am moving from plus to minus, therefore minus 100, minus 30, and two currents are flowing here, that is I3 minus of I2, that is equal to 0. So on simplifying, we'll get 30I2 minus 35I3 is equal to 100. So what is the current that is flowing through 30 ohm? It is the difference between the two currents, that is I2 minus I3. Therefore, use Kramer's rule in order to solve the value for I1, I2 and I3, and will able to get current through 30 ohm is 2.62 ampere. In a similar way, using mesh analysis, you have to find current here I1, I2, I3. So this is the network that is shown. So use Kirchhoff voltage law for mesh 1, mesh 2 and mesh 3. So write Kirchhoff voltage law for the first mesh 7, because I am moving from negative to positive. So it is positive 7 in the direction of current, therefore minus 1, and two currents are flowing here, I1 and I2 in opposite direction. Therefore I1 minus I2, minus 6 because I am moving from positive to negative, therefore minus 6, minus 2 into I1 minus I2 is equal to 0. On simplifying, I am going to get this equation. Similarly, apply KVL for loop 2. So we'll get the equation I1 minus 6I2 plus 3I3 is equal to 0. So depending on the mesh tree, there is a voltage source and tree resistance. Therefore, we can write minus 3, that is I3 minus I2. I2 is in opposite direction. Therefore, minus I3 minus I2 minus 1 into I3 minus 2 into I3 and I1 we have written, that is equal to here minus 6. So here after taking this 6 to right hand side, it becomes minus 6. Solve this equation, reduce this equation. So using Kramer's rule, that is using Kramer's rule, one can find the solution for I1, I2, I3. That is nothing but R into I is equal to V. So here R is nothing but this one. So here I am going to write minus 3, then 1 and 2. Then I am going to write here then 1 minus 6, 3 and 2, 3 and minus 6. This is our resistance matrix. Here I am going to find what is I1, I2 and I3. So what is the voltage source that is given? This is nothing but here in this equation I am going to see here 1 is present, 0 is present and minus 6 is present here. Therefore, I am going to write minus 1, 0 and minus 6. So this is the equation. So let us call del is equal to determinant del is equal to this. Now what is del 1? Del 1 is nothing but the column, first column is replaced by minus 1, 0, minus 6 and we have to retain all the values. So minus 6, 3, 3, minus 6. Using determinant, you find what is the value of delta and what is the value of delta 1. So what is the current expression I1? I1 is nothing but delta 1 by delta. Similarly, we have to find delta 2. So delta 2 is nothing but replace second column by minus 1, 0, minus 6 by retaining the remaining column, that is minus 3, 1, 2. Again here the last column 2, 3, minus 6. Find the value of delta 2. So what is I2? I2 is delta 2 by delta. So what is delta 3? So delta 3 is nothing but replace third column by minus 1, 0, minus 6, and then here retain the previous value. So second column is 1 minus 6, 3. Find the value of delta 3. So what is I3? I3 is delta 3 by delta. So on solving that, we are able to find I1 is equal to 3 ampere, I2 is equal to 2 ampere, and I3 is equal to 3 ampere. Now let us solve this problem. Find current that is flowing through this RLC circuit. So the circuit given is AC with a frequency of 100 Hz with 100 volts. So R value, L value and C value is given, that is 10 ohm, 10 Henry and 10 Farad. So the impedance of this circuit is given by R plus JXL minus JXC. So XL is nothing but inductive reactance, XC is nothing but capacitive reactance. So the total impedance of this network is given by R plus J into XL minus XC. So now from the basics of electrical, we know that the expression for frequency sensitive element, that is inductive reactance and capacitive reactance, is given by XL is equal to 2 pi FL and XC is equal to 1 by 2 pi FC. So on substituting the value of L and the frequency, we are going to get the inductive reactance and capacitive reactance as shown. So what is the total impedance? Total impedance is 10 plus J 6283.179. Now this is in rectangular form. Now I want to convert this into the polar form. So here when this is in A plus IB form, that is rectangular form, we are going to calculate here the amplitude, that is Z, that is given by A square plus B square to the power half. So substitute and find the value. Amplitude is given by, or magnitude is given by this value. So what is I? I is nothing but V by R. So in this case it is I is equal to V by Z. So what is V? V is 100 volts. And what is Z? Z is this value. Substitute and we will get the answer, this 15.9 milliamperes. So this is the next problem. We have to find I1, I2 and I3. Given this network, we have to find the current in the mesh I1, I2 and I3. So let us assume current in the first mesh is I1, second mesh is I2 and third mesh is I3. All is assumed in clockwise direction. So let us write the mesh equation, mesh 1, mesh 2 and mesh 3 equation. So now we have to write the mesh equation here. So let us write here 10. So now let us consider mesh 1. So when we consider this mesh 1, we are moving from negative to positive. Therefore here positive voltage we have to write 10. We are moving in the direction of assumed current, therefore I1 is flowing through 0.2 ohm minus 0.2 I1. And again in the direction of current, there are two currents, I1 in the direction and I2 in the opposite direction, therefore I1 minus I2. Similarly, minus 3 into I1 minus I3 is equal to 0. So on simplifying this, we are going to get minus 5.2 I1 plus 2 I2 plus 3 I3 is equal to minus 10. So this will be the equation for first mesh. Similarly, let us consider the second mesh here, which consisting of resistance 5 ohm, 4 ohm and 2 ohm. So we'll start from this writing equation. So 0.2 into I3. So here we are going to write the equation minus 5 I2 minus 4 I2 and I3 are in opposite direction. Therefore, we have written minus 4 I2 minus I3. It becomes this minus 2 I2 and I1. So on simplifying this, we'll get this equation. 2I1 minus 11I2 plus 4I3 is equal to 0. Similarly, so let us write the mesh equation for third mesh. So here we are going to see zero point 0.2 ohm, 3 ohm and 15 volts. So let us write the equation. I am moving in the direction of current. So this is minus zero point 0.2 into I3. I3 is flowing here and I am moving from plus to minus. Therefore, it is minus 15 volts. So here two currents are opposite in direction. So minus 3 into I1, I3 minus I1 minus here 4. So here I3 minus I2, that is equal to 0. So now simplify this and write the third equation. Now use the Kramer's rule in order to solve the value for current I1 and I2. So let us write the value of R in these equation in the form of determinant. So let us consider the determinant here. So the first one is minus 5.2, second value is 2 and third value is 3. And here we are going to get 2, we are going to get minus 11 and then 4. Then here I have 3 and 4 and then minus 7.2. And here I have to write here I1, I2, I3. So that is equal to what are the voltages that is present in this network. It is minus 10 according to this equation, 0 and 15. So if you have calculator, that is Casio, that is FX 991 ms. So directly you can solve this equation by using the equation mode. So in equation mode, you have to enter whether the unknowns are 2 or 3. Here you enter the unknowns as 3. Immediately you will going to get the prompt that enter A1, enter I'm now entering 5.2 minus 5.2 and then it will ask B1 and then C1 and D1, that is this. So these are the values of A, B, C and D. So you enter, on entering and pressing equals, you are going to get the answer, this one XYZ, which is nothing but I1, I2, I3 as shown. So this is the next problem. Here we have to find once again the current in the mesh, that is mesh 1, mesh 2 and mesh 3. Here we have a dependent voltage source. So we have a dependent voltage source between this mesh, first mesh and second mesh. Therefore, we have to consider here this IA, whatever the current that is flowing through 50 ohm is nothing but the difference between these two currents. So on observing this network, we are going to write the first equation IA, that is nothing but I2 minus I3, because they are in opposite direction. So now let us write Kirchhoff voltage law for the first mesh. So I am moving from minus to plus 100, it is positive, minus 5i1, again minus 15i1, and again I3 is in opposite direction. So minus of 15i1 minus I3 will yield this. Again here there are two currents flowing I1 and I2. So I have written here minus 10i1 plus 10i2 is equal to 0. Simplify and you will get this equation. Group I1, I2, I3 and you will get this equation. So now let us consider the second mesh. So we'll write the second mesh minus 10 here, I2 minus I1, again here minus 50, I2 minus I3. Here there is a dependent voltage source. Here the first sign I encounter is minus, therefore it is plus 10. What is IA? IA is I2 minus I3, that is equal to 0. Simplify, you will get this equation. So write the equation. So minus 15 I3 minus I1 minus 25 I3 minus 50 I3 minus I2, that is equal to 0. So simplify this and use Kramer's rule in order to solve. So the Kramer's rule can be written like this for the equation. So we have here two equation, 1, 2 and 3 equation. Therefore you can write the Kramer's rule like this: I1, that is R11, R12 and R13, and then here we can write here 10, and then here minus 50 and then 40, and then for the third equation 25 and then 50 and minus, here it is nothing but and then you write here I1, I2 and I3, that is equal to, you write minus 100, then 0 and 0. Now use the previous technique in order to find I1. So I1 is equal to delta 1 by delta, I2 is equal to delta 2 by delta, and I3 is equal to delta 3 by delta. Even if you have a scientific calculator with three unknown components can be found by using the equation mode in the calculator. Now let us consider this problem. The statement of the problem is: find the current through 4 ohm resistance in the network using loop analysis or mesh analysis. So here you are going to see the voltage source 50 at 0 degree, 26.25 at minus 66.8 degree. So this is nothing but the polar form of representation of the voltage source representation. So consider the three currents that is flowing in the mesh 1, mesh 2 and mesh 3 in the clockwise direction. Here we are able to see the AC components that is present in this network. So writing the first equation, so 50 at 0 minus 5i1 minus j2 i1 minus i2 is equal to 0. On simplifying this, we are going to get this equation, that is first equation. Similarly, so let us write the second equation for mesh 2 using sign convention. Minus 4i2 minus of minus j2, here two currents are flowing, I2 minus I3 minus j2, here again I2 minus I1, that is equal to 0. On simplifying, we will get this equation. So now applying KVL to loop 3, here we have polar representation. So let us convert this polar representation 26.25 at minus 66.8 degree into rectangular using the calculator. So now we can write the equation minus 2i3. So I am moving down, therefore plus here the value of this rectangular value minus j2 minus of minus J2 because I have here capacitive element. So it is nothing but I3 minus I2 is equal to 0. So on simplifying, I am going to get the third equation as shown. So let us write this in the form of determinants or matrix. So now the R value, impedance value is written in this matrix, current value in this matrix, and then the voltage source is written as shown. So now use Kramer's rule in order to solve for I1, I2 and I3. So what is the equation for I1? So I1 can be written like this. I1 is nothing but delta 1 by delta. So I2 is nothing but delta 2 by delta, and I3 is nothing but delta 3 by delta. So use Kramer's rule in order to solve the currents in three loops. Find Ix and Vx for the circuit shown using mesh analysis. So on careful observation, we are going to see here there is a presence of independent voltage source, independent current source, dependent current source and dependent voltage source. Therefore, we have to write the equation based on the observation. So there are two mesh, that is mesh 1 or loop 1, loop 2. So on observation, we are going to see in mesh 1, the current flowing in this mesh 1 is 3 ampere. So let us consider Ix is equal to 3 ampere. So what is the direction of assumed current? Clockwise direction. What is the current flowing? Anti-clockwise direction. Therefore, here we have to consider I1 is equal to minus Ix. So what is Ix? That is 3 ampere. Therefore, the current in that mesh 1 is minus 3 ampere. So now let us come to the second loop. So here I2 is nothing but Vx by 4. This is the current, dependent current source. So but what is Vx here? Voltage across this 1 ohm resistance, which is nothing but the product of resistance and current. So two currents are flowing in opposite direction, I1 and I2. Therefore, it is written here Vx is equal to I1 minus I2 into 1 ohm. So on simplifying here, we are going to get the expression for second mesh I2 is equal to I1 minus I2 by 4. So we already know what is I1. Substitute I1 here. We are going to get the current I2 zero point 0.6 ampere. So what is Vx here? Vx is equal to 4 into I2. Now what is the value of I2? Minus 0.6 ampere. So substitute here, we'll get Vx as minus 2.4 volts. So this is the next problem statement. For the network shown, find current through 4 ohm and 6 ohm using mesh analysis. So now we are going to see here there is a current source that is present between the two mesh. Therefore, these two mesh forms a super mesh. So let us consider the current I1, I2 and I3 as shown. So what is the current flowing through 4 ohm? It is I1. What is the current that is flowing through 6 ohm? It is I3. So here on observing this, we can write I2 minus I3 is 0.5 V1. So what is V1 here? So we are going to write the expression for V1. V1 is nothing but I into R. So this is V1. So it is nothing but the current flow into resistance. So there are two currents flowing in opposite direction. It is I1 minus I3 into 2 ohm. So solve this, you will get V1 is equal to 2I1 minus 2I3. Now what is I2 minus I3? So it is nothing but here substitute this V1 here and you will going to get I1 is equal to I2. that is the current whatever I1 flowing in mesh 1 is equal to I2. At the same time, apply KVL to the super mesh, that is this mesh. It is minus 10 I2 minus 6 I3 minus 2 I3 minus I1 is equal to 0. So simplify this, we are going to get the equation 2I1 minus 10 I2 minus 8 I3 is equal to 0. Now apply the KVL to the mesh here, minus 110 volts minus 18 I1 minus 2 I1 minus I3, that is equal to 0. This is the first mesh. Therefore, write the equation, simplify, use Kramer's rule in order to solve I1, I2 and I3. So what is the current that is flowing through 4 ohm? It is I1, 5 ampere. What is the current that is flowing through 6 ohm? It is minus 5 ampere. So the next problem we solve using mesh analysis is this. Statement is like this. Find current through 10 ohm resistor using mesh analysis. On close observation of this network given, so there are two independent voltage sources are there, and here we are able to see dependent voltage sources in mesh 1 and mesh 2. Therefore, we can write here the current I1 in mesh 1 is Iy and current I2 in mesh 2, that is nothing but Ix. So what is the current that is flowing through 10 ohm? So on observation, it is the difference between I1 and I2 that is written here. Now apply Kirchhoff voltage law to mesh 1 or loop 1 here. So I am moving from negative to positive. So it is 5. I am moving in the direction of current assumed. Therefore minus 5 I1. What is I1? It is I minus 10 Ix. What is Ix? Ix is I2. I am moving from plus to minus, therefore it is negative. So now here two currents are flowing through this 10 ohm, that is minus 10 I1 plus 10 I2, and here I am moving from plus to minus, therefore it is minus 5 Iy. What is Iy? Iy is I1, that is equal to 0. On simplification, I am going to get here the current I1 is 0.25 ampere. Now apply KVL to the second loop. So minus 5I2, I am moving from plus to minus, therefore minus 10. Again here I am moving from minus to plus, plus 5Iy. What is Iy? Iy is I1 minus here 10I2 in the direction of assumed current plus 10I1 is equal to 0. On simplifying, I am going to get the value of I2 as minus 0.416 ampere. So what is Ix? Ix is I2. What is Iy? Iy is I1. So we have the value of I2 and I1. Substitute here. So what is the current that is flowing through 10 ohm? It is the difference between the two current. So we are going to get 0.66 amperes. Equations are written using Kirchhoff current law, that is current entering into the node is equal to current leaving the node. Therefore, here we'll observe in this network there are three nodes, two main node, that is here whatever wherever I am pointing V1, V2, and this will be the reference node. Therefore, here we are going to write the Kirchhoff current law at node V1, V2. So at node V1, what are the currents entering? Therefore, it is nothing but V1 minus 10 divided by 2. That is nothing but current is given by V by R. So V1 minus 10 by 2 plus what is the another current that is here leaving, that is V1 by 4 plus V1 minus V2 by 5 is equal to 0. So here at node V1 we have written this equation. Simplify, we'll get the equation 0.95 V1 minus 0.2 V2 is equal to 5. In a similar way, apply KCL to node V2. Here V2 minus V1 by 5 plus V2 by 8 plus V2 minus 20 by 10 is equal to 0. Simplify this equation and write the final equation, which consists of the voltages V1 and V2. Now use the Kramer's rule or the option that is there in the scientific calculator to solve two variable or three variable. Here we have two variable, therefore we can write A1, B1, C1, A2, B2, C2, and finally on pressing equals in calculator we'll get the value of x and y like this. Now I will show you how to find the values of V1 and V2 using the calculator Casio FX991MS scientific calculator I have. So on turning on the calculator, you have to press more and three times you press. So you are going to get equation. Search for EQN and press 1 here. After it will ask how many unknowns are there in the equation. So I am going to select 2 here. On selecting 2, I am going to get here on my screen A1. What is A1? So I am going to enter A1 0.95. On pressing equals, when you press equals, you will get what is B1. So I am going to enter minus 0.2. Again I am going to press equals. I am going to get C1. What is C1? The calculator is asking. I am going to enter the value 5. So again I am going to press equals. So it is asking A2. What is A2? So A2 is nothing but minus 0.2 I am entering. On pressing equals once again, it will ask B2. What is B2? B2 in the equation is 0.425. Again press equals. It will ask you what is C2. C2 is 2 here. Click equals. So on pressing that equals, we are going to get, that is, x is equal to 6.94 and y is equal to 7.97 approximately. So what is this x and y? It is nothing but V1 and V2. If you don't know Kramer's rule, directly using scientific calculator, you can calculate the unknown values using calculator. Find the node voltage Vx and Vy in the network shown using nodal analysis. So for this network, observe there is a current source here that is independent, and here we are going to see here there is a voltage source in series with a resistor. Along with this, we are going to see independent voltage source 10 and 15 here. So whenever current is entering into the network, this is the redundant element. Therefore, let us not take this into account. So KCL equation we are going to write at Vx. So 12 ampere is entering 12, and here I am going to see 20 volts in series with 5 ohm. So use current to voltage to current source transformation, that is 20 by 5 is 4 ampere is entering into this node. Therefore I can write 12 plus 4 is 16, that is equal to here Vx by 10, it is written Vx minus Vy by 5. So simplify, you are going to get 0.3 Vx minus 0.2 Vy is equal to 16. Similarly, apply the KCL to node Y. So Vy minus Vx by 5. Again Vy by 5. We are going to see here Vy minus 15 by 5. Also, we are going to see Vy, since negative comes here, so minus of minus 10 volts is nothing but Vy plus 10 divided by 5 is equal to 0. Simplify the equation and we are going to get the value Vx and Vy as shown. Since two unknown variables are here, Vx and Vy, use scientific calculator as explained in the previous explanation, that is equation mode with two unknown variable a1, b1, c1, a2, b2 and c2 with the signs, and you will get x and y value as shown. And what is x? X is nothing but Vx voltage at this point, Vy is voltage at this point. Find all the node voltage V1, V2, V3 using nodal analysis. So this is the network shown. Here we are able to find a voltage source that is present between two nodes. Therefore, we are going to see here the presence of a super node. Therefore, on observation, we are going to see V3 minus V2 is equal to 20 volts. That is the first equation. So let us consider the node V1 and the super node equation V2, V3. So what is the equation that we can write at V1? That is V1 minus V2 by 2 plus V1 minus V3 by 10, that is equal to, here we are going to see the currents, that is minus 5 and minus 4 is entering into the node. Therefore, on simplifying, we are going to get this equation. Similarly, at supernode V2 and V3, we can write here V2 minus V1 by 2 plus V2 by 4 plus V3 minus V1 by 10 plus V3 by 5, and there are two currents, that is minus 4 and 10. So if we consider that minus 4 is leaving the supernode and minus 10 is leaving the supernode, we are going to get 14 here. So from the first equation, what is V3? V3 is equal to 20 plus V2. Since the equation we have here is 2, substitute V3 is equal to 20 plus V2 in both equation 2 and 3 and get the equations, so that we are going to get V1 and V2 as unknown. Use scientific calculator in mode, equation mode, and enter A1, B1, C1, A2, B2 and C2 to get X and Y in terms of V1 and V2 like this. What is V3? V3 is nothing but 20 plus V2. What is V2? Substitute 20 plus 2.22, you will going to get V3 22.226 volts. That is the value of V1, V2 and V3 for this network that is shown using nodal analysis. So in this module, we have solved some problems on mesh and nodal analysis, source transformation. Thank you, happy learning and keep learning.